Hi, today I'm going to be showing you how to create Choropleth maps with R. These are super useful for any geospatial analysis that you're doing, working with spatial data, and especially for the social sciences to study different demographics in a certain area, things like that. So I'll show you how to do that in R. So in R, first, you'll need to download some packages that we haven't used yet. So one of them is called SF, which stands for Simple Features. So this is basically just a package that lets you work with spatial data. It's very useful. It works really well with shapefiles, and it is pretty intuitive if you're used to working with data frames and plots that we've seen with ggplot2. So first install that, and then another package is called SF headers. This isn't necessary, but it's useful if you want to convert your shape files and different spatial data into something that you might be more familiar with. So you can change a shape file into like a data frame, so it might be easier to work with. So that's the first thing to do. And then once you read in your data, you can get spatial data on many different areas on the web. You want to look at this CRS. So for both these, this US Census and then the New York City zip codes, we have the same NAD83 CRS, which is basically a mapping. So whenever you work with spatial data, there is something called the cartographer's dilemma, where any type of spatial data is going to be manipulated and skewed from reality in some way, because you're going from the globe, which is three-dimensional spherical, into a two-dimensional plot. So it's going to be skewed in some way. So the CRS will let you know what kind of data you're working with and how they projected it. So you want to make sure any data that you're going to combine into one map has the same CRS, and we'll get to that later as well. And here you can see that the once I join those two data sets together to just get the census from New York City, the data looks a little messy in this SF package. So that's when you might want to convert to a data frame to work with it. And the column names are very ambiguous, DP and then a number. When you're downloading shapefiles, mostly you want to make sure that they come with some kind of data dictionary, which most things do if you're downloading them from any kind of repository. So this one, I just have to cross-reference what these column names mean when I'm actually doing the mapping, which once you get to the mapping, in the SF package, they have this plot function, which works very similar to ggplot2, but it's just specifically for mapping, and it's very simple to use. They have great documentation about it from the SF package. So when you are looking at mapping data, you want to use, of course, like the latitude and longitude will be used automatically to create the actual map part. And then you decide what you want to look at. So what kind of demographics or any variables that you want to see in that certain area. So I decided, for an example, to compare the vacant housing units to the occupied housing units in New York City, just to study which boroughs are more occupied, like more people live there. So like Midtown Manhattan has a little bit less than, say, Queens and Staten Island. So you can compare like the occupied, Brooklyn is very occupied. So in the first two, I'm using a break called the Jinx break, which splits the data to minimize the variance and minimize the variance between or within categories and maximize the variance between the categories. So that's just one option for breaking the data. Another option is just equal breaks, which is the default in this plot function. So that will go into deciles of the data. So it's a little bit easier to compare two variables using that equal breaks compared to the Jinx, which is very specific to the actual map that you're looking at. And once I mentioned the CRS, so I got another data set with a different CRS right here. So you want to make sure that you convert that when you're comparing those data sets. And this is just an example map from that. So you have to make sure that the CRS aligns and is compatible with each other to create a map. There are many other things you can do with maps, but this is just an example, and I hope you enjoyed.